What's up, everybody? This is Aircrete Harry, and today my guest is Mike South of Monolithic Domes. Hello, Mike.
Hey Harry, how's it going?
It's going pretty good. So, Mike South is the owner of Monolithic Domes, or one of the owners, and his company and his father, David South, inspired me to want to work with airforms. I saw in their videos how simple it looked to build domes. I seen their airforms being used in Haiti to build domes, and you had people who had zero skills and were instantly able to pick up a stucco sprayer or just even a trowel and begin building domes, cement domes, concrete or ferro cement domes. And they're really amazing because of the speed that they were able to build. And watching these people in Haiti, it's a third world country, barely had any tools, and they were building these big, beautiful domes, and it was amazing. And when I was looking into buying my own piece of property to build a home, I went through a whole range of different style homes that I could possibly build. I took a bunch of different workshops, but I finally landed on the domes, on the airform system. And Mike at Monolithic makes the airforms. I even have a custom airform that I'm preparing now, the foundation to build my hyperbolic paraboloid, and made at Mike's shop there at Monolithic Dome. And it's really, I've been guiding a lot of people towards you guys, where I came up with a system using Tyvek house wrap. I think I might have been the first person on the planet to make an airform using Tyvek house wrap. So I'm happy that was the first to do that. It's a low pressure system. I always tell people you have to be very careful as to how you build, because the entire thing could collapse if you don't do the right process. So I'm constantly guiding people towards monolithic domes for the reusable airforms, because to me, they just make so much more sense if you're building multiple domes. If you're building two or more domes, then for me, it's a no-brainer to use a reusable airform if you're using my building method. But Mike and Monolithic Domes, they have a completely different building system called the monolithic dome system. And Mike's going to explain to us how that works. Before we get to that, Mike, so how long have you been in the dome building industry?
Yeah, since I was born into it. So I've, in fact, I've got a few pictures here. Maybe I can just show real quick.
Yeah.
It's kind of fun. The first monolithic dome to ever be built was built in Shelley, Idaho, as a potato storage. Not quite as pretty as the ones we built today, and neither was the camera's ability to take those pictures. The potato storages have this central column so they could blow air inside of them, like, or through the potatoes to keep them fresh. I don't quite understand that system as well as my dad did back there when they lived in Idaho. Their company before that had really been spraying polyurethane foam. So they had sprayed foam and they'd foamed tons of potato storages, and they knew a lot about the ventilation systems and stuff it took to keep those potatoes where they were supposed to be. There's a
That,
picture of
that
my
dome,
dad.
that dome looks huge. Any idea what size diameter that was?
Oh, I can't remember. I think it was 110 or somewhere around there, 90.
Wow,
But it was
for
around
the
the 100.
first dome, for the first dome
Yeah.
they built, that was huge.
Yeah, he didn't try a small one first. He went right for the big ones. That's right. And if you knew my dad, that's the way my dad was, it's like, hey, no, this will work and let's just do it.
I love it.
I also love discussing with my dad when he was here, and he was telling us about the first domes and the amount of reinforcement they put in there. And look at that. That is spaced. I think Dad was telling me that they spaced it almost 2 or 3 feet apart at first. Not as much reinforcement as we put in today. And there's a picture of me, yeah, on my first
There's
first
the
job site.
young Mike with his shades
Yeah,
on, looking real
that's me
cool.
on the right with my safety colors. It's pretty fun. This picture behind us here, I think this is the Emmett High School. I could be wrong about that. And this was back in the days where Dad would, when they built the first domes, they would strip the airform off, and they would, to expose the inner polyurethane foam layer. but they quit doing that quickly because it's pretty challenging to coat polyurethane foam and keep it coated well. There's just another fun picture of me there on the job site. So to answer the question, I've been doing it for a long time.
Yeah, you've been doing it all your life.
Yeah.
So when domes are first inflated, I was taught by my buddy Dan that it's called a birthing process. Is that what you guys call it also? Is it a birthing process?
I guess we're not as creative with the name. We just call it inflating. We had to quit calling it blowing them up because people don't like to hear you say you're
Yeah.
blowing up buildings. Yeah. But yeah, we inflate them. Mhm.
So you guys do a lot of inflating. Okay, my buddy told me when the air form is first inflated, they call it a birthing. So I always thought that
Mm.
was cool. So I was gonna ask, how many birthings have you been to?
Oh man, I've been to my fair share of them. That's for sure.
Yeah, that's awesome.
Plated one in Pensacola, Florida. I've got a pretty cool video of that, but I might be jumping ahead.
Yeah, when you speak of Florida, I always think of the Eye of the Storm dome that's been in so many news reports. They've withstood multiple storms there where the homes are all around that one dome home were all destroyed more than once and they were rebuilt. Meanwhile, the dome is still standing strong, because of the geometry, because of the dome shape. A lot of people might not be aware, but like in Rome, they were famous for building the arches. And they always talk about the Roman arch, how strong it is. And this is why the Colosseum and all their bridges and waterways had multiple archways, because the arch for stone is the strongest shape you could build for the stone, because the stone, like concrete, likes to be in compression. So that's why they built these arches. Now, a dome is an arch that's 360. And so that's why the dome is known to be the strongest structure you could build. And because of the shape, it's aerodynamic. Tornadoes don't affect it, hurricanes don't affect it because it's aerodynamic and the wind will just go around it. Tornadoes can't lift a dome up because of the geometry. And so this is why that dome in Florida and any dome are, in my opinion, just a superior structure you can build. And then the second strongest, which is what I'm building next, is the hyperbolic paraboloid, because it's also got two curves. It has a curve in one direction and then a curve in the opposite direction, like a horse saddle. That would be a hyperbolic paraboloid shape. So this is what this structure that I'm about to build, the hyperbolic paraboloid, is. It's basically a 24-foot dome cut in half, stretched out, and then with a slope going in the middle. And so with the two curves, I get a lot of strength with that. So yeah, let's go right into it. You got some videos or photos to show with the dome? Maybe you got a picture we can show the eye of the
Yeah.
storm.
Before I get too excited about showing you all the cool houses we have and then getting into all sorts of trouble and getting out of trouble, I should say. Yeah, let's start with maybe that video just kind of explain to everybody how domes are built, shall we?
Yeah, that sounds great. Now this is the monolithic method for building domes. And they have two methods, if I'm not mistaken. They have the monolithic version, and then they have the eco shell version, which is the version that I work with.
Yeah, exactly. So both versions start the same way, don't they? Here that with the concrete floor or the ring beam. This particular project here was for a fertilizer storage, kind of a small one. The fertilizer storage is interesting. Ammonium nitrate is a big thing in Texas, where the ammonium nitrate has been involved with a few of these explosions, particularly the one in West Texas, where they just leveled that down almost with an ammonium nitrate explosion. So Texas has been very sensitive to that, and the fire marshals are telling all of these facilities that you've got to find a fireproof way to store that. Well, the dome is just an automatic win, a complete concrete structure, nothing to burn. And so we've built quite a few of these, and some of them are quite small, like this one. This is actually only, I think it's like 50 feet in diameter. It's a pretty small dome. The other method is the ring beam, pictured here, is just a concrete ring that's poured on the ground, and the airform is then spread over and attached to the beam or the floor, and that's where we inflate it. Right, we don't blow them up anymore. We inflate those. The airform is incredibly strong. As you know, that air pressure is not very great. 2 inches of water column. Water column pressure is real simple to measure with a tube full of water. You can measure the difference in the water level. And in PSI, it ends up being about 0.07 PSI.
And there's a name for that tool that can sometimes be a tongue twister for me, which is called a what?
Manometer.
There you go, manometer.
Yeah. Yeah. Super low pressure, but the amount of weight that it can lift is incredible.
Now, this is the other
Like,
benefit of the dome airforms if you purchase them from Monolithic is you can have all your different protrusions pre-sewn into the airform. So as you can see here, he has the window protrusions are in the airform, and they also have that for the doorways. So it's really nice to speed up the process, and you'd have your window forms there already. And so that's what you're seeing in this image are the protrusions in the airform already built.
and that's one of the natural progressions of our business has been is that nobody wants the same airform. Nobody wants the same shape of a dome. Most dome customers are very creative. They want to have fun with their structure. And so we have gotten really good at doing some really creative inflatable shapes, which today we'll get to see a whole lot more of those. This is the next step in the monolithic dome construction process. So once the airform's inflated, we spray polyurethane foam. You can see in this foam the wire hangers that are sticking out from it. Those
Yeah.
hangers are there for the rebar, and you can see a couple of the hoop bars tied there. And
Yeah.
this dome is, I think it was 4 domes hooked together. So you can kind of see this, we call them saddles. So this archway in between the domes is you could walk in between the different ones.
Yeah. I like to also describe this as a like a soap bubble dome because you have multiple bubbles or domes connected to one another like a soap bubble. And so
Yep,
that's the type of shapes you have inside.
that's a good way
And,
of describing it.
and how thick is the polyurethane foam sprayed on?
3 inches typically.
Now, for most people, if you don't know polyurethane foam, and I'm assuming this is the closed cell foam,
Yes.
it is considered the best insulation you can get. It's number one for insulation. What's the R value for that per inch?
Well, our value is only about 7.5. I think it is per inch per foam. But
Yeah,
we could start a whole other video about R value, and my dad called it the R fairy tale, right?
yeah,
On our website, if you're interested in what we're talking about here for just a minute, my dad wrote a big article about the R values and what they mean and where they were derived from. And so us in the polyurethane foam industry, we uh, we we recognize that the R value isn't necessarily a fair measurement of insulation, especially if you're trying to measure the difference between polyurethane foam and fiberglass insulation, which can get wet or have once it gets damp or air blows through it, the R value plummets to almost nothing. Where polyurethane foam, it's a closed cell structure, so it's waterproof. It seals anything you spray it on. It increases the rigidity of any building or structure that it's sprayed onto. So that's not something that is a secret. Most people understand that, but foam is the best insulation that there is. Yeah.
yeah. And the good thing is, after this airform's sprayed, technically it would hold itself up if you ever had a power failure and your blower shut off. That's always a fear of mine, and I prepare for that because I've run into that issue before where my generator or the blower just stops and it's a rush to have your backup. So I always suggest to people who've come to my workshops, you want to have a backup blower, backup generator, everything backed up because once you've inflated that airform, And with my system that I use, the Eco Shell, you're spraying that cement on there right away. And if you have a power failure, you could potentially lose all the cement you've done, and it's a real nightmare. And I've run into the issue before, but the good thing about this spray foam is it's holding itself up. Now, as Mike says, there's an article on monolithic.com. If you did a search, and I'll leave a link in the description, but if you do a search for R value fairy tale and type in monolithic, the article should come up. It's a really good article because what's done in these R value tests is everything is done in laboratory conditions. And so they have the most ideal situations for the materials they're testing. And like Mike just said, if you don't have a good airtight structure and wind is getting in, it doesn't happen with domes. But if you have a regular structure where wind is getting in, it can the fiberglass insulation if it's not been installed correctly, or if it got wet, if there's a leak, then the insulation is doing absolutely nothing. But with this polyurethane spray foam, you eliminate all of those issues because it's known for sealing up the leaks, stopping the air, and being waterproof. So many great benefits to using polyurethane foam, especially in the dome projects.
And then there's the dome itself has insulative qualities. We'll go over that here in a minute, but that just make it one of the most highly energy efficient structures that there is. So this picture is of the rebar hangers. So we were a little bit out of order since that last picture showed the hangers were already there. So in this stage of the construction process, the first 2 inches of polyurethane foam would have been applied. Rebar hangers are then placed, and then another inch of polyurethane foam is put on top of those stickers to hold them in there. We call them stickers or rebar hangers interchangeably. Then the structural steel is tied in next. This building pictured, I think, is got number 3 rebar, so that's 3/8 inch diameter, and it's tied at 12 inches on center. And you can see that the hoop bars are the first bars to go on. They're pretty easy to keep spaced at 12 inches. But we have a pretty creative pattern as we go up with our vertical rebar so that we can kind of maintain that spacing.
Right. And that's because the wedge shaped that happens, or the gore shaped that happens with the domes, because you're wider at the bottom and you're tapering to the top. And so that's why they have to come up with these rebar patterns like you see there.
And on the left, you can see this is another invention of my dad's. It's called the Paxis Polar Scaffold. And it is one of the greatest tools we have. It rotates inside of the dome with a real simple electric motor. It gives us a really good access to the building. And the last step is installing the shotcrete, which here you've got to spray a lot of concrete in your stuff. That's a fun job, isn't it?
Oh yeah, it's a blast. Fortunately for me, I haven't sprayed on the inside of a dome, and I hear there's plenty of rebound, so you could really be a cement person once you're done.
Yeah, I actually prefer spraying concrete inside than outside.
I there's so many benefits to spraying on the inside. I mean, for me, I love the idea of you could build this house in wintertime because you're on the inside. Right. The weather, once your air form's inflated, it doesn't matter what the weather is outside. You're working indoors, protected from the elements. That's the other big benefit to using this system, where if you live in an area in a climate that's got bad weather all the time, or it's always rainy or whatever, this is a system to really consider because everything is done on the inside. And so, yeah, I love the whole idea of this.
Yeah, when I growing up building domes, this was my favorite part of the process, was spraying the shotcrete. It is really fun.
Because that's
Fun to
making it
see.
permanent. Once you spray it, oh man, look at the beauty of this. Wow, that's
This
huge.
is a dome we built last year, just north of the Dallas-Fort Worth area. And it is a huge home. This is a deluxe house. He's almost finished with it. I think the second quarter of next year we're going to go up there and we'll do a feature article and show the inside. But he's got a. It's hard to see in the picture, but over here you can see where the sunken movie theater is. He's going to have a little bar in the movie theater, and he's got a huge master bedroom and a huge open area. He's got some
Well,
very large skylights at the top.
what's the size of this? Was this also
Um,
one airform or multiple airforms?
one airform. Yeah.
That's
I
beautiful.
really like single inflation buildings. I think they're so much more fun and they're economic to build because you can just inflate it and go, right?
Yeah.
But they're so impressive and so much fun to be a part of.
So this looks like 40 feet wide by 150 feet long. Like how big is this? This looks
I
huge.
believe the center dome, the big dome, I think is 50 feet in diameter. I don't remember it exactly, but it's about 105 foot long in total.
Yeah, that's wow. Yeah, that's awesome. See, I'm getting excited about my hyperbolic paraboloid because mine's is 24 feet wide and 64 feet long. So it's just a huge structure.
That's
And
awesome.
the design that I got, I have an option to put it well, any of these domes pretty much. I have an option of putting it on a stem wall if I want more height on the inside. So the first one I'm building is really meant to be my garage slash workshop. What my wife and I decided to do is just jump on the hyperbolic, see if we could get that built before winter, so we can have a really large space to live in, and this way I could get more work done during the winter time because I didn't really have a large indoor space to work. So that's why I'm really pushing to get this hyperbolic paraboloid done. I'll have the video out and it'll be fun. But this here reminds me of what I'm looking to build. And this is what I like for a lot of people. You know, they don't necessarily need this size, but this same type of airform, a little smaller, you can just see for yourself how much space there is on the inside. And once the airform is inflated, how long would you say, Mike, it takes to actually get the shell completed?
Yeah, most shells are done in 2 weeks after the airform is inflated.
This is incredible time. 2 weeks to have a structure up that will never burn down, withstand hurricanes, tornadoes, earthquakes, depending on how thick you make your walls, can be bulletproof. Mike has videos. I've also shown on my channel his videos of them shooting their domes. You know, I like to bring up the bulletproofing because really it's kind of like the test where they shoot a 2x4. For me, if your dome will take a 380 round, I think it could take a 2x4 shot
Yeah,
at 12
yeah,
at 200 miles an hour.
yeah.
Yeah, this is beautiful. I love this expansive space. And 2 weeks, people, 2 weeks with a good shotcrete crew spraying it up.
Yep. So I'm going to go through and show some more interior pictures. So we'll just kind of let this play through. This is actually my house that I live in here. We'll go through, look at some interior pictures, but dome homes are quite beautiful. So although they are incredibly impervious to tornadoes and they're super energy efficient, they can be quite beautiful on the inside, and they create a space that's unlike any other to live in.
And I think it's important for people to realize because a lot of people hear dome and immediately think that they need all custom furniture. And I've proven this by walking
Yeah,
through your father's double dome, two 40-foot domes in Texas. And you see everything is standard furniture. And so you don't need to worry about needing custom anything. You can get away with having wherever you shop for furniture
right.
and you'll be good to go. It's no issues.
Yeah, that is a, I grew up living in a dome. Like, my whole life, I have lived inside monolithic domes. And so to me, some of those questions are silly. Like, well, of course, you don't need to buy round sofas, to live in your.
Yeah.
But, but yeah, it's a pretty common thing. The first thing they think of is, well, if everything's round and everything else has to be round too. And well, of course not.
Yeah, so that's a funny thing, and that's something I'm always getting asked by people. What do you do about furniture or cabinets? And I'm like, it's all good. You can
Yeah.
easily put a flat wall in front of if you have a high curve, and this is why I like stem walls personally in the domes that I built. Always put a stem wall where you could be against the dome. You could be 6 feet tall and standing against the wall, and you still have that space. But some domes have more of a curved end, don't have the stem wall. In those situations, you could easily build a flat wall to put your cabinets and everything you need, and it still works beautifully.
And that rolls right into the next thing that I think is something that domes do for these next generations of builders is we have to stop building these throwaway buildings. You know, we build a building for McDonald's, and after 15 years, when it's served, they just tear it down and they build it on. Just waste, waste, waste. When we build our domes, right, and ours, they are permanent structures. And so, as we move into this next generation, where we're looking at our carbon footprint, and not only are we trying to be energy efficient, right, but we're trying to be efficient in what we do and the materials we use, and how so we're a little more intelligent in our thinking. I think that just plays right into the strengths of the monolithic dome. We're building a permanent structure. There, my dad used to say that there were 500-year structures, but I mean, you look at the Pantheon in Rome. How old is that thing? How
Yep,
long are our domes going to last? They're going to be here for centuries. My
yeah.
kids and their kids can live in the same house that I built.
And
And
the other beauty that I love about that is, like you just said, your kids and your kids' kids will be able to live in that dome. God forbid there's ever a fire, you don't lose everything. If you
right,
have an interior fire, okay, things on the inside will burn, but your structure will still be there. You can come back home. And if there's an exterior fire, depending on your filtration system, this is what I'm about, because let's just say, there's a fire here like there was recently in Hawaii, right? There's massive fire. Let's say you leave your home because of smoke. Smoke is the biggest killer in fires. And so let's say you leave your home and there is a fire, overtakes your home, but your home will still be standing. You'll come back and you can go live in it. Now I live off grid here. I have nothing but woods around me. And my whole thing is having a air filtration system. Basically, it's 80 pounds of charcoal that air is filtered through. So this will filter everything in the air out. And so if you are prepared, if you have the foresight to think ahead, you'll have shutters that you can cover your windows with if there's a fire, and you could actually be safe indoors, because sometimes it might not be safe to try to get out of the area. There's all kinds of scenarios that can happen. But to think that your home is a safe haven where you could stay even in the event of a fire, I think for me is huge, because whenever you hear about disasters or you watch these channels, I watch these channels on preppers, and they're always prepping and say they got to have a go bag in case something happens. I'm like, no, I'm building a dome home where if there's anything that happens, I go home. And that's
yeah,
the safe place, is home. What's better than to be home and know you are safe from people? If things get crazy, you're safe from gunfire, you're safe from fire, from where, I mean, there's so many things to keep you safe when it comes to these cement structures that we live in. And as Mike said, when it comes to the environment and being all eco-friendly and everything, the benefits of the monolithic dome is they use very little cement. It's a thin shell system. And so you might have anywhere, maximum would be 6 inches at a base and tapering down to 2 inches at the roof. But, like my domes are no thicker than 2 inches in the cement for the structure. So that's the other benefit, is you're using less material to build these structures because of the dome shape. and being under compression, which is the ideal situation for cement and concrete, you can't beat it. So that's something else to mention, how they're thin shelled structures, giving them plenty of strength, reducing the cost of cement. You don't need as much cement to build one of these domes than you would a foundation for a traditional home.
Just in that same subject, I think before we go into seeing some really fun projects that we're working on right now, is just to finish, tie a bow on the energy efficiency question. I like to show some slides from the California Energy Commission years ago. They wrote a paper on how to passively heat and cool buildings. And part of that study was to analyze wall systems and to try to decide what the best wall system was to mitigate the temperature swings. So this chart is showing the outside highs and lows of the outside temperature, then how well this wall system would block that from coming inside your home. So the basis of their design was a thin steel plate with 1 inch of insulation. So it was a pretty basic little wall system.
Mhm.
The next wall that they tested was a 2.5 inch thick wood wall with 1 inch of insulation. You can see that it cut that by about 30%, right?
Yeah.
So we've got 0.7. So then they went into the concrete walls, right? So we're going to build a big, thick concrete brick wall or concrete wall, and we're going to have an inch of insulation on the inside. And you can see I did a pretty good job, right? You've only got
Yeah.
0.5 of that temperature swing coming inside. But this is the fun part. And this is why I show this slideshow where I can roll back and forth. Take those same components and you swap them around. 0.05. So that is 10 times better. Same materials, just in a different orientation. So what does this tell us? It tells us that we insulate against these temperature swings from the outside. The concrete, it does a couple of things. It's obviously an insulator itself, but what's interesting is I like to call it a thermal battery, like the Prius on the road, right? The hybrid. That concrete, that mass of concrete, it takes in a lot of energy to change the temperature of concrete. So if you live inside a concrete home that has insulation to protect it from the exterior temperature swings, that concrete is going to stay cool. I'm a Texan, so I use the cool analogy.
Mm-hmm.
It's going to stay cool inside. So if my air conditioner goes out, which at my house it has done this a couple times, where my air conditioner goes out and it takes me days to realize that it's happened, because the concrete is so cold and there's nothing outside to affect that temperature. The only thing that can affect that temperature is me cooking and cleaning and breathing, letting the windows, bring in some solar energy through there. And so it is incredibly insulated, not only because we're using the world's best insulation, but because the configuration that the dome is. And most buildings today are the opposite, right? They'll have a concrete block wall and then they insulate it on the inside. And while that's a pretty good system, just swap them around and look at the difference it makes. So the dome takes advantage of the concrete mass. It puts that to work.
Try to explain to people and why I build the way I build, in that when I'm building with the eco shell and I'm using Aircrete or Epic material as the insulator, I like to make sure that inner shell that's going to be on the inside of the dome is a stucco mix, a sand cement mix, because of what Mike just said. It acts as a thermal battery. So if you have air conditioning on, those cement walls will get cold and radiate cold. And then if it's winter time and you have the heat on, they'll absorb the warmth of the heat and radiate the heat back at you. And that's why this system is great, of having your dense material on the inside and your insulative material on the outside of your structure. For this reason, because people are always concerned about R value, R value, R value. And like you said, and like your father said in the article, is basically a fairy tale, because there's so many other factors that come into play that aren't taken into account. And so I added those points to bring up, so that if someone's getting something a custom house. Maybe they're not going monolithic and they're going, where Aircrete Harry style, and they want to use Aircrete. I wanted them to have a full picture. So I explained why what you just explained, why it's better to have your insulation on the outside because of the thermal mass you have on the inside. I also
Right.
spoke about special paints. I have paints with ceramic beads. These ceramic beads, it's like a flower, it's like a powder, but they're so tiny and they have a hollow vacuum inside of these ceramic beads that once mixed into paint, or what I'm doing now, mixing it into cement, acts as an incredible thermal barrier. And I've proven this in my video where the dome I built in 2019, I had the one Mr. Buddy heater on the inside, and this was in December. And the heater got the dome up to like 55 degrees, and that was it. After painting the dome on the inside with this paint, it brought the temperature up 20 degrees. So if you're building a custom home and you're using custom insulation or whatever, other factors that need to be spoken about and with your structural engineer and with the building people are all these special materials that are out now that we can get, like this paint. And as an example, the company who sells this ceramic bead paint made an example on their website where they had a canvas tent and they painted the inside and outside of this canvas tent with this special paint that has the ceramic beads in it that act as a thermal barrier. And they simply said you could live in this tent all year round, winter, summer, because of the efficiency of this ceramic beads. And so, again, now you could build a structure in Texas on a hot climate. Say you want to build an eco shell, and then you could literally just paint it with this special paint and it'll do the same, have the same effect. Now, the problem is you probably wouldn't get approved to build this because people have to learn about these things, about these special materials and how they work. But, it's just as an example, there are other materials out there that exist that can really increase the efficiency of heating and cooling. Now, another thing that increases the efficiency of heating and cooling in domes that we didn't discuss is, again, the geometry of the dome. If you have heat along the perimeter of your dome, it'll rise up and curl and come back in. So you have this nice circulation that happens inside of the domes as well, which is what's going to also help for heating and cooling.
Yeah, one of my favorite things to do is to walk people in our manufacturing facility. You've been in there, right, Harry? And then
Yep.
you walk in the Texas heat, and you walk in and it's just as cool as you would want it to be. And you look around for the air conditioner and you almost can't find it.
Yeah.
We
It's
cool this
amazing
whole
how cool it
entire
is.
place with two little mini split units like you would find in people's homes. It cools this whole entire 12,000 square foot manufacturing facility.
Yeah. This is a facility that they call the Caterpillar, and they've actually painted it to look like a caterpillar.
Yep.
And it's huge. It's how many domes make up this caterpillar?
I don't remember exactly now that you've asked. I think it's 8 or 9.
Yeah. This is their room where they make their airforms. And as you can imagine, they make airforms that could be hundreds of feet in diameter. And they have these sonic welding machines there. And I don't see it now, but probably have a CNC cutter too, right? For cutting the material.
Yeah, in fact, that's what you're seeing here. This is the plotter cutter here. So it'll plot the seam marks and match marks and different things, and then it'll cut out the fabric right here on this table.
Is that vacuum down? Because the fabric looks really flat.
It is. Yeah, it's a vacuum table.
Oh, okay. Yeah.
About 80 foot long. We had about an 80-foot long vacuum table. But our panels are often much longer than that. We've had panels where we've had to pull it off of this table 4 times before we're done cutting just the one
Wow.
panel.
That's huge.
And we've had some pretty large domes built through here. See if I can find a picture of the welders for you real quick. We have these are radio frequency welders.
Yeah,
So they
that's
use the same microwave technology, right? That you use to heat your food up. They use microwaves to heat the material and melt it together essentially.
okay. I never really comprehended what a frequency welder was, but that makes sense. It's if it's like a microwave, those send out frequencies. So yeah, cool. I had no
Now
idea
the
that was
great advantage
microwave.
with that is like there are hot air welders and different wedge kind of welders in the industry, but the great thing about these RF welders is that you can measure the amount of energy that goes through the bar. And so the quality control is the main goal there. We want to make sure every weld is done exactly right. And so if there is like foreign material or moisture or something there that would prevent that weld from happening, the computer would actually know that because it measures each weld and it'll actually kick out an error and say, listen, there's something wrong with that weld. You need to go
Wow, that's really
revisit that.
cool.
So
And you have
you mentioned the air pressure, right?
uh-huh,
And how critical that is. Imagine how critical it is to have these massive air structures with men inside working, that the
yeah.
seams are working and that they work well. And so we take quality control pretty seriously.
Yeah. And I think you also have a smaller version of this machine as well.
We have a couple smaller machines, but mostly we use the same machine, even for some of these multi-dome structures. There's one in California. I always thought it kind of looks like Pikachu almost with these
Yeah, yeah.
Gothic arch augments there. This is another one that we've
Oh
built in
man.
Fredericksburg, Texas.
See, I don't know if it's just me, but I just see nothing but beauty in this. It's to me, it's so beautiful to see, and that's just one air form. This is amazing.
Well, this project is really fun, actually. The patio back here is actually a 40,000 gallon water cistern that we built. We just basically a swimming pool construction method, right? We dug it out, earth formed it, sprayed the tank. We built a center wall that kind of helped give the lid a little more support. And we did this with the single form method, right? So we just set up one single side form and we just shoot the shotcrete right against the forms. And then we just form and pour a lid right on top of that thing.
Yeah, that's really cool. I like the way you made those arches there for that support wall. That was really
Oh,
nice.
this tank looks awesome inside. Um,
For a moment, when I saw those arches, I thought you were going to put a piece of glass there and have a giant aquarium.
yeah, yeah, that's a shot from the inside afterwards.
Yeah, that's great. 40,000 gallon tank. Oh yeah, that's perfect.
You were talking about the Romans in that arch, right? There's just
Yep,
some
yep.
archwork there for you. So this is a huge water tank, and then what we're doing is we're capturing all of the rain. So on any section of the dome, if it gets rain, it's going to get funneled into that tank.
Oh yeah,
And
that's great.
this area of Texas is pretty dry, but when it does rain, it really rains. So our goal was to create a catchment system that could, even in the deluge, we'll capture every single gallon of water that comes down.
Have you done a catchment system like this before on domes?
My dad built a few. This was Mike's first one. But David up there in the north, they built quite a few water tanks. What we have not. This is our first one.
Nice. I like the way it looks. I like so that catchment is going all the way around the domes to catch.
Yep, all the way around.
Oh yeah, that's great.
And even I don't know if I can find the right picture. Oh, this is before the catchment system was installed. But even around where the augments are, so this trench terminates right against this augment.
Right.
And so even water that lands on top of those augmented, that's what we call the doors. They'll just go around the augment right into the tank. This rain that's pictured here happened while we were doing this, which was the first time it had rained on the whole entire project. Of course, it rained while we were working on this. Kind of washed a little bit of it away. We had to kind of come back and redo it a little bit. But this dome is beautiful on the inside. We've done a couple really fun things. These round windows are really fun. They're actually installing the glass on those as we speak. And then these windows are really fun. These big, large. See if I can get my cursor out of the way. That's going to be completely glass at the end of it, but then she's going to have pillows and stuff there, so you can lay
Oh,
in the
nice.
window and
Yeah.
read and stuff while you're doing it. Going to be a very impressive structure. We'll have pictures of the glass work and stuff. I've got crews there now that are installing it.
Is
So,
that like a 3 foot window sill for them to sit down on?
yeah, it's about 3 feet. Yeah.
Yeah. It's a beautiful looking structure. I mean, I don't know if it's just us, right? Because we're into domes, but the curvature and those arches on the inside is just beautiful.
Yeah. Well, the what 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 is interesting to me about this, and I get on my pedestal and preach for a minute, is that the craftsmanship in the world seems to be fading away as we go to these throwaway buildings like we talked about. As we throw up the same old walls and the same old roof, and there's not a lot of the craftsmen. My crew that does this shotcrete work, they have been doing it for 30 years, and they are real craftsmen to do these kind of curves and how beautiful all of these elements tie in together. And that I am very proud of my crew and what our company is able to do because we are making some beautiful structures.
Yeah, I concur.
They are in North Carolina right now. They just got rained on by that small hurricane that they're doing. This is the dome that they inflated this yesterday.
Oh,
This one's
nice.
smaller. It's a 37-foot dome with two 34-foot domes off onto the side.
And it has the one blower. That's the blower right there inflating.
Yep, that's the primary blower. We've got a secondary blower sitting on standby. I think they'll hook that
That's the
up here in a
backup,
little
right? The
while.
backup blower.
Yeah, yeah, we always have a backup. This is the customer here. This is the customer here getting ready to throw the switch,
Big
or
old smile.
give. What did you say? This is the birthing moment,
Yeah,
right? The final push. So he's gonna flip the switch, and then he'll have an inflated home.
so cool.
The other one that we just inflated the week before was in Pensacola, Florida. This is going to have a two-story section here where the home is. So this phase, we've just inflated the airform. You can see our scaffolding laying here on the floor
Right.
that we'll assemble after that. We really rocket forward there into the foam is done. Steel is there. We've got some electrical conduits that are being put in. And see if we can find some shotcrete pictures for you. There you go. So the shotcrete is done. This is a rough textured shotcrete. And you can see here on the floor, we've got all of the rebound.
Nice.
And this dome was, like I said, this was just a couple weeks ago. So this dome was brand new. I could show a
Yeah.
lot of pictures. What do you think you'd like to see for pictures? Do you want to see some storm video? I've got a little bit.
Yeah, let's show the storm.
Yeah, that's always the kind of the fun stuff to see, right?
Oh,
So
absolutely.
we built the house in the Keys, out Key West, Florida area. This one is actually on Cujo Key for Paul Tinsley. And we can flip through some of his pictures of his finished dome. We just recently did a feature article on his house, which just looks fantastic. Look at that view.
Oh, yeah. Right on the water. See, I like that, everything was thought out where the dome is built on those columns. So you're above the ground. So God forbid to have another storm. There's a storm now in Florida. Water can surge and will go under the structure. I mean, you might have some damage to your vehicles or whatever, but you could still be safe in the house, during a storm. The house is beautiful. I love that staircase. Oh yeah. This is very, very nice.
Yeah, he's got a beautiful, beautiful home that he's built there. I like how he's incorporated that bottom space with the columns to make it kind of a fun area.
Yeah, absolutely.
This is on our website, so obviously your viewers can go and check it out anytime they want. I think the fun, for us is these kind of shots, right? Look at
Yeah,
that. So Hurricane Irma hit his place, and I've got a little bit of a video here. And he stayed inside the house while it was happening. He didn't evacuate. He's like, "No, I'm just going to ride it out
that's what I would do.
in the home."
I say I
And
got a dome for that purpose. I'm riding.
that's right. I'm going to ride it out. So he did, and he said it's just incredible. It's incredible how quiet it is inside. You look outside, you see that, but you don't hear it.
Yeah.
It's just there.
I'm
And the
amazed all
story,
the time because I'm here in Colorado and I'll look at my security cameras and I'll see the trees leaning sideways. And I didn't even realize it was that windy because you just don't feel it inside the dome. The
yeah,
other reason you don't feel it is because normally people live in flat structures, square homes, and so those flat walls will get hit by wind and can cause vibration, which makes a lot of sound and all.
yeah. Well, Paul, he told me a fun story that the eye of those hurricanes is as real as you've seen in the movies. When that eye comes, it is just peaceful and the sun shines. And he said that while the eye was there, he ran downstairs to tie up a boat that he had noticed during his, that it wasn't quite tied up. He said he barely made it back in the house. He scrambled up the stairs, barely could get the door shut when he got in. But
Yeah.
he his house is going to go through more of these. It is, and he'll be ready.
Oh yeah. Yeah, it's a beautiful looking home. And what size was that home?
It probably says here in the article, give you the exact, but I'm going to just guess it's about a 45-foot dome there, and this one was
Okay.
probably 36 or 38,
Yeah.
something like that.
Yeah, it's beautiful.
Javier will tell you a story. So Javier is our main crew chief there, the guy that does most of our this kind of work, and he was talking about the challenge of mounting these window bucks and stuff on the top of those stilts.
Uh-huh.
You can see there's no room around there, so it's a little bit of a challenging build up on there, but totally doable. This was one of my favorite structures, the pineapple, and this one is in Belize. We have a guy that David Spellings is just a wonderful guy, and they retired there in Belize, and they've built this. There's a picture of David there.
So it's
He
a
built this.
5-story dome.
Yeah, it's not very big in diameter. It's only like 25 feet or something,
That
and
is
it
really
is
cool.
it is such a cool house, just right there on the coast, also. And what's really fun is all the woodwork there. It was done, with Belize labor and Belize wood, and it's just beautiful inside.
Oh yeah. Is that the cap that they made on the ground
Yeah,
before
that's what I was
putting it
just
up?
wondering. I wonder what the story is there.
Oh, it's the thatch cap.
Yeah,
It's not needed, but for the look, he put it up there.
yeah, he wanted to blend in.
Yeah, it's blending in. He's got
It's
his
blending in.
pineapple home.
Yeah, look at that.
Oh, look at that. He's all pineappled out. Cool.
It's fun. We talk about the craftsmen. You go to these other areas, and those craftsmen, they're there doing the work. Look at that. And it's really fun to look at these pictures. There's a ton more. I mean, we could spend hours going over some of these new homes that we've built. This is my brother Dave's house that we built up in Providence, Utah. Beautiful.
Yeah, really nice. Is that
This
a
one has
50 footer?
what's interesting about this home is that the center dome isn't actually it's more of like an eyeball shape. It's like an elliptical dome. It's pretty
Ah,
fun.
okay.
But he's got the radiant floor heating in there. I think that's the thing that's the most fun for me and guys like you. That's that radiant heating and how well it just warms the whole dome up.
Yeah, I mean, I love walking barefoot, so there's nothing like having concrete floors that are warm or tiled floors and they're all warm to the touch.
Yeah. he actually, what's interesting about the dome is that because of the energy efficiency, he couldn't use, and he still doesn't to this day, the thermostat system that came with it. He has to turn it on and manually shut it off after about 15 or 20 minutes.
Oh,
Because
wow.
if he lets it come up to full temperature, it will bake them out of the place. Uh, I don't know if he's come up with anything more elegant yet, but right now, the last time I talked to him, it was kind of a manual control because it would put too much heat into the house if they weren't careful.
Yeah, that's a great problem to have.
Yeah,
It's so efficient that you got to manually turn it off early.
that's exactly right. So again, our website is full of really awesome dome homes. This is another one, kind of like Dave's. I like to point out the airform on this dome, just how smooth and elegant those transitions are. They're
Yeah,
just beautiful structures.
it's no wrinkles in the fabric. It's just perfectly smooth.
Yep, and I'd be remiss if I didn't do a little selling while I was on your channel.
Really?
We have a couple fun things to just drop in. We have an ebook that talks about dome living, has about a big section of floor plans and pictures and little fun things about how to get started. I think that it's a great first step for someone who's interested in getting in to dome living.
And speaking of this, I know you guys usually have two workshops a year. Am I correct? Do you have another one coming up next month?
Yep, we've got one coming up next month.
When does it start next month for anyone interested in
Let's
getting
take a look
involved?
right there. We got the fall 2023 workshop coming up, the 12th to 16th.
Now, another big reason I love domes, and maybe you can speak to more of this from the domes you just showed, is I love the speed at which you could build the structure. Now, I'm very specific with saying that because we're not talking about finishing the house, but I'm talking about finishing your structure so that you can begin working on the inside. So, what's the average time for most of the domes you've just showed us to finish the structure, to have a standing structure?
Yeah, we can talk about that pretty easily. Though, so the one that I had showed earlier, the dome that we're building right now in North Carolina with those three domes that were put together, that dome will be done probably by the end of next week. So that is a week and a half. Now that structure is a little simpler than say like Paul Tinsley's where it was up on the piles, or like my brother's house that had the octagonal looking we call them Orion stem walls. So the Orion stem walls, they took on Dave's house, for example, that took about a week for us to build those walls. And then we were about 2 more weeks building the dome. So 3 weeks from just the concrete floor to a finished concrete structure.
And this is what I'm getting at for my audience, and I'm also projecting this towards the people who have recently lost their homes in fires. These structures go up fast. The benefit of the monolithic system and their eco shell system is the speed. And I just personally love the speed at which you can build. If you contact any contractor who's building traditional stick frame home, you're going to be looking at 3 months, probably minimum, to have something built. 3 months. Whereas the dome structures, monolithic system, and their eco shell system are, you just heard it, 3 weeks for your structure. Now your structure's up. You could spend the next 3 weeks on the inside of it, finishing it. It's huge. So, Mike, another question I wanted to ask you was I noticed when I was visiting Monolithic Dome Institute there in Italy, Texas, your office dome has a massive amount of dome missing from the front. If I'm correct, is it like 40% of a dome could be missing and it still be structurally sound?
Yeah, that's correct. We've got quite a few domes that are cut away almost completely. In fact, I've got a fun picture of a house that's got some of that.
Because that's a lot, like 40%. And obviously 40% on one side is what I'm referring to, but you could easily remove 40% in multiple areas, and
Oh
altogether
yeah.
add up to 40%. And you can have like these big window openings if you wanted, and to let tons of light in, and big doorways if you wanted, and you wouldn't have to worry because you'd still be structurally sound.
This is kind of a fun home that has this one's about to come out in on our website as a kind of a revisit to this dome home. Look at this. This is just half a dome.
Yeah, that is cool. Look at all that light that comes into there.
Yeah.
Yeah, that's really nice.
It's not exactly what you were talking about, but it was right on top of my mind because again, we're just revisiting this home to do an article that I love the snow.
Well, that looks like 50% of the dome missing, and it's
Yeah,
standing.
that's right. Here's some shots from the inside
That's the
of that
same.
woodwork.
That's the same dome.
Okay. Hmm.
Yeah, that looks really nice.
That's a different one. But yeah, pretty
So
cool.
when it comes to the dome, I know you guys build domes for people, and I know you also teach workshops so people could build their own domes or get into business building domes, whatever they
Yep.
choose. I'm guessing most people get into business. Like, I purchase all my equipment from you guys. I got my shotcrete machine, my blowers, ton of airforms. I probably got, I don't know, like 8 different airforms from you guys. And I could easily go into business if I wanted, building domes for people with the airforms that I have.
Yeah.
Building with the Aircrete Harry style. And the only difference between what I call the Aircrete Harry style monolithic is I'm building monolithic's eco shells, and I'm adding my insulation to the outside of that, because you could vary the thickness of your Aircrete or your styrocrete or styro Aircrete, more insulative mixes. And this was mainly done to make things as affordable as possible. The eco shells, you would not want to build an eco shell in cold climate area solo, but eco shell with an insulation on it. Some people have sprayed the exterior of the eco shells with the spray foam. In my opinion, if you were going to do that, you're better off just building monolithic style right from the get-go, because it comes
Right.
out much more prettier, much nicer. The airform for monolithic stays in place, giving you another protective barrier. I know some people choose to put a stucco coating on top of that for extra protection. That's another option people have for that. Depends on, your budget, of course. The again, the thing for me with these airform structures is the speed. Now, the other thing, I was just mentioning the eco shells. Those are reusable airforms. Now, it's very unfortunate the fires that happened in Hawaii most recently, but these fires are happening every day all over the country. People are losing their homes. Unfortunately, people are losing lives as well. And so really my big push for domes has been to have a safer place to live. Have your home be a safe haven. No matter what's going on in the world, you have this dome that will protect you from all of it. It's resistant to all of it. I really technically can't say like proof, like fireproof or
Right.
anything proof. They're technically resistant to everything, but it's so resistant you can almost say it's proof. So they're really good. And so a big suggestion that I like to make to people in situations like this now, for example, like in Hawaii, where a whole little city or town is gone, just burned to the ground. I mean, it's terrible. Once it's time to rebuild, I want to throw this option out there for people. And that would be, get together with your neighbors. You could come up with a nice multi-dome home design, and you can have an airform made at Monolithic. They can make an airform, and they have 2 different types of materials as far as the warranty goes. And we're talking about multiple years warranty. And you have these airforms that are reusable up to 100 or more times, depending on how well you take care of the airforms. So people who are in desperate need now, very low money, everything burnt away, you could come together. This is what I would do. Get an airform. Let's just say it's a 1,200 or 2,000 square foot space, 2 or 3 dome, like you just saw us showing in this video. And you can help each other, taking turns to build each other's homes, especially since it's so communal in that area and people are tight. You could quickly have a structure to live in, and be a safe structure that would be permanent, that you would not have to be concerned with a fire happening again. Obviously, again, smoke is the biggest issue. And I've always thought of all these things when I looked into bunkers and things. And so these filtration systems that they sell for these underground bunkers and things like this, you can make yourself. They're not difficult. You just need a powerful blower and charcoal, right? And the more charcoal you have, the more filtration you get. And this is to prevent smoke. So God forbid there's another fire, you could stay in your house with this filtration system on, giving you fresh, clean air still, and knowing you're safe from the fire because you're taking all the preventative measures. To give you an example, in Europe, last time I was in Germany, and even in Holland, and even in France, in Paris, home structures, homes have gates that come down in front of their windows. It's like a shutter. You pull this cord and a shutter comes down, so you have a metal barrier on the outside of your glass window to protect you from storms and fires and things like this. So taking all those things into account, you can build a safe structure relatively inexpensively using the eco shell style airforms, and really build back and get back to living safely, and not be concerned with another fire like this happening again. So that's something I'm a really big fan of. you know for I'll give you an example. For 15,000, I could buy the airform that I got, which is 24 feet wide and 64 feet long. It's a massive space, right? And that's probably overkill for most people. You don't even need anything that big. But you could get something like that for about 15 grand and build 50 or 100 homes with that one airform. This is how you could get back to living, just get back to living again, get back to some normalcy. So this is for the world. Like if you're anywhere in the world, especially in these large fires, like the other one happened in California a few years ago, you know, hundreds of homes were gone. And the time is going to take to rebuild that. It could be
Well,
done
and
with.
we've also seen it on the at the federal level where FEMA has come in and funding tornado shelters up through Tornado Alley. FEMA has put in a bunch of money, and we've built a lot of domes for school districts, and they get a lot of funding from FEMA because it doubles as town's tornado shelter. And the same thing can be done in Hawaii and other places. It just like the first response buildings can be dome, fire resistant
Yeah.
buildings, and then and back to what you were saying about on the steel shutters and stuff. Most of the domes I've seen catch fire, there was no special shutters or anything. I mean, the fact is, if you don't have fuel piled up laying up against your dome, you're not going to ever get any real flames up
Yeah.
against your house.
Yeah.
What happens is you get these embers and things, or if you're in a heavily wooded area, you could get some fire. But the domes I've seen go through fires, they don't even look like they've been touched. The one that got scorched pretty bad, he did have some fuel right next to his house. He had a shed where he kept all of his firewood and the fuel for his lawnmower in this little shed next to his dome. And that sucker burned for a while. And the wind had pushed the flame up against the dome. And so there was this black streak up the side of the dome that tapered off to nothing. And we just went up there and we took off about a half inch of the foam that had kind of turned black. And we didn't even refoam it. Like there wasn't enough foam missing to even warrant
Right.
foaming it. We
Yeah.
just painted it. It looked great after we were done with it. Like
And
nothing had happened.
that's a great example that Mike just gave. Reason I say look into the shutters, those windows in Europe, they're designed to tilt open from the top, and then you turn the handle and you can open it like a door, and then you can walk out. That's
Yeah,
the
that's
same
cool.
window that has the metal shutters. Now, the metal shutters, I say you want to have, like for these intense fires that have been happening, the shutters will help stop the heat from coming in. Because I've been in my car driving past a house on fire, and it had to be 100 feet away, and I felt like I was in a campfire with the fire right next to me. The heat is just so intense.
Yeah.
And again, you don't have to have these concerns in the dome because, like Mike said, there's no fuel. There's as long as there's nothing to burn, you don't have to be concerned. If your trees or whatever are like 25, feet away or something, it's not up against your structure. And so, anyway, I just been watching the videos recently about the fires, and every time I see it, immediately my first thought with fires and tornadoes and hurricanes is if they only built a dome, they wouldn't have these problems.
Or if they had a community shelter to escape to, it's not a crazy idea. I mean,
Yeah,
it's a
yeah.
simple thing to do, build it.
You have a church or some community, some type of structure that's safe,
Yeah.
but
A
for me,
plan.
what I prefer is your actual house being
Yeah,
safe.
of course.
so,
Yeah.
so that you can just, oh my God, the sirens are going on. There's a fire and a hurricane tornado. All right, just close the windows and let's, watch the DVD player, and you
Yeah.
wouldn't even know what's happening outside. It's literally, I might make it sound dramatic, but it's literally like that. Inside of the dome, you would not know there was a hurricane or a tornado or anything happening outside. It's just so peaceful inside there.
Yeah.
It's really like that. It's crazy. Again, I'm a big fan of domes for the speed at which you could build, for the fact that you never have to worry about losing your entire everything, your life savings or old photographs and things that you cherish. It happens every day to people where they lose everything. And I always say if you just build a dome and just take some small steps, you wouldn't have to worry about it. Even if you love your traditional square house, like Mike said, if you take some kind of precaution, build a 16 or 20-foot dome in your backyard that you could use for storage and emergencies. Okay. Then you have something. You don't need an underground cellar or bunker. A dome, the way it works and everything will keep you safe. Just build in your backyard. Every backyard you have a dome. If you live where there's hurricanes or tornadoes, or if you're in heavily wooded areas, you should have a dome for your protection of your family and whatever property you have that you want to keep safe. Even if you did have to leave the town, put your things that you want to keep safe in there, lock it, and you're good to go. So anyway, I'm a big fan of domes for a lot of reasons. I've made videos about it. We discussed it today about that. Again, Monolithic Domes is having a workshop next month, and I highly suggest it because their building method is really probably the most superior system you can build when it comes to the level of insulation you have, the fact that you're building on the inside of the home. You could be building in the winter in Alaska and you'll be fine because you're building indoors with the heat on, and you could literally go to the extremes. You could be in the jungles of South America and it'll be a monsoon season, but once that air form's inflated, you're working nice and dry on the inside. You could set up everything on the inside of there. There's so many different benefits to it. The good thing is the monolithic domes, because of the method at which they're constructed, are approved in probably every state in the United States. You can get building approval. Monolithic has engineers that will work with you. They have designers that will design. I went through the process with Monolithic where I had my home designed and I went to their engineer and I did all the steps. Only reason I didn't finish is because I ended up not building on that property because it was heavily sloped and it was like 5 times more expensive to build on a slope than on a flat ground. So that's the only reason I didn't get my dome finished by Monolithic. Otherwise, highly recommend looking into it. They have an online course, which I've also purchased in the past, and very reasonable price for everything. The workshops, the online course, the design that they'll do for you, the structural engineer. They've been doing it for many years. Mike's entire life, they've been doing these domes, so they have so much experience and knowledge when it comes to it. They'll teach you how to build it, or they'll send a crew out to build it for you. So either way, you're going to have something you're going to be extremely happy with. I guarantee you, because I visited many, many monolithic domes in Texas and in here in Colorado. And I'm always, and you can watch on my channels, I've always been extremely impressed and happy with them. And I'm personally happy with the structures that I'm building now. And the one I will be building, my hyperbolic paraboloid. Hopefully I could get that done by the month of September. That'll be awesome. And I'll have it on the class
That'll be really great to see.
for everyone to see. And maybe Mike might even come out to see the Bali going up.
Let's do it.
But Mike, it's been a pleasure having you. Thank you for sharing all the videos and pictures you have. Just sharing your knowledge with us. It's been really great, and I appreciate that.
Thanks for having me on.
Absolutely. Mike, take care. We love you all, and we'll catch you later. Peace.
Thanks, Harry. See you, man.
Mike.